everyone, so we are back with another video, and in this video we are going to discuss how to find out area under a curve, and this requires the concept of integration with limits. So before I move on to this concept, let's quickly go over integration. So let's say we have y equal to ax to the power of n given to us. Any question in this format where a is a constant. And we have been asked to integrate this expression. So integral y dx. So this becomes integral ax to the power of n dx. So since a is a constant, we can put this outside the integral sign. So a integral x to the power of n dx. So there is a formula of integration, and that is x to the power of n plus 1. So we are going to add 1 to this value of n, and then we are going to divide it by that new value. Okay, so a into x to the power of n plus 1 by n plus 1. So let's look at an example. So let's say we are given y equal to 2x cube, and we want to integrate this. So 2 is a constant, so we can put the 2 outside the integral sign like we had done in this step. So 2 integral x cube dx. So if you compare our question with the format that we had discussed earlier, so a is basically 2, right? And n is equal to 3. So if I follow this formula, so it will become 2 into x to the power of 3 plus 1 by 3 plus 1. So that becomes 2 into x to the power of 4 by 4. So that's half, so half x to the power of 4. So here, since no limits are given, so we have to add a c at the end. Okay, and if limits were given, then we have to use the limits to find out the final answer. So let's look at one example. So let's use the same question, y equal to 2x cube. This time, let's say the limits given are 2 and 1. Okay, we have to find out this integral. So 2 is called the upper limit, whereas 1 is called the lower limit. So this becomes integral to 1 2x cube dx. Same concept, 2 is a constant, so we can put that outside the integral sign. So 2 1x cube dx. We are going to use this formula again. So that will leave us with 2x to the power of 4 by 4. And this time we have to put square brackets and write the limits on this side. So I'm writing the upper limit on top, followed by the lower limit in the bottom. Right? So now again, 4 is a constant, so I can put that outside the brackets. So box bracket 4 2 1. So this again simplifies to half. So half bracket x to the power 4 2 1. So next step is simple. You just have to substitute the limits in place of the variable. So first I have to put the upper limit in place of x. So half bracket 2, which is the upper limit, that is raised to the power of 4 because we have x to the power of 4. Then minus, next put the lower limit in place of x now. So 1 to the power of 4. Right? So this simplifies to half 2 to the power of 4 minus 1. So half bracket 16 minus 1. Fine. So 15 by 2 is our final answer. So here we don't have to put this plus c. Why? Because in this question, limits were provided to us. So when there are no limits given, only then we put this c. And if limits are provided, then you don't have to put a C. Okay, so we are going to use this concept only when we are finding out the area under the curve. So let's look at this example. So here see, the question says, the diagram below shows the graph of y equal to 7x minus x squared minus 6. So this is the equation of the curve which is given to us. They have also sketched the diagram. So here, this is the curve which has been provided to us, right? So this curve has this particular equation, and they have shaded this region of the curve, and the question is, find the shaded area, and we have to give our answer as a fraction in simplest terms. So if we are given a question like this, so let's say we are given something like this, right? And this is, let's say, x1, this is, let's say, x2, and this is the shaded region, and we are asked to find out the area of this shaded region. So how will we go about it? So area is basically found out by calculating the integration of the equation of the curve. So integral the upper limit, which is x2, because this value is greater than x1. So x2 will be the upper limit and x1 will be the lower limit. So x1 and is written in the bottom part. Then the equation of the curve, dx. So this is all that we have to keep in mind when we are doing these sums. So here, if you look at the diagram, see this point is 6, 0. That means the x coordinate is 6 and this point is 1, 0. So the x coordinate is 1. So from here we can say that the upper limit is 6 and 1 is the lower limit. So area under this curve will be integral. x2 is now what? 6, which is the upper limit, and x1 is 1, which is the lower limit, y dx. Now what is y? Y is this expression, basically the equation of the curve. So integral 6(1) 7x minus x squared minus 6 dx. So I basically substituted the expression of y over here. So now if you want, you can integrate it all together, or if you want, you can integrate them separately. So let's do it separately so that's easier for everyone to understand. So I'm just continuing over here. So here 7 is a constant, so I can put that outside the integral sign. So 7 integral 1 in the lower part, because that's the lower limit, and 6 is the upper limit, so that should be written at the top. X dx minus integral, again 6(1), same limits, x squared dx minus 6 integral dx, and again the limits are 6 and 1. If you want, you can write a 1 over here as well. So now the next step, integrate it. So x squared by 2, right? Why? Because this is basically x to the power of 1. So if we use this formula that we had learned earlier, this formula basically, so x to the power of 1 plus 1 by 1 plus 1. So that's x to the power of 2 by 2. So that is what I've written over here. Write the limits on this side. Minus x to the power of 2 plus 1, so that's 3 by 2 plus 1, which is also 3. Again, write the limits on this side. Minus, so here we have integral 1 dx. So integral 1 dx, if you want, you can think of it like this. X to the power of 0 dx, because anything to the power of 0 is 1. So I can write it as x to the power of 0 dx. So again that concept, so x to the power of 0 plus 1 by 0 plus 1. So that's simply what? X to the power of 1 by 1, and that will give us just x. So minus 6x bracket 6 and 1. Okay, so just put the constants outside the bracket. So 7 by 2 bracket x squared 6 1 minus 1 by 3 bracket x cube 6 1 and minus 6 bracket x 6 1. Okay, so I have completed the step so far. So next step is to what? Basically substitute the limits in place of x. First we have to give the upper limit, then minus the lower limit. So 7 by 2 bracket, upper limit is what? 6. So 6 square minus the lower limit, which is 1. So 1 square minus 1 by 3. Again, upper limit is what? 6. So 6 cube minus lower limit is 1. So 1 cube minus 6. Again, upper limit is 6 minus the lower limit, which is 1. So 7 by 2. So that is 36 minus 1 minus 1 by 3, which is 216 minus 1 minus 6 into 5. So 7 by 2 bracket 35 minus 1 by 3 bracket 215 minus 30. Okay, so we have plugged in the values and we have to now give our final answer. So see here they have asked for the answer as a fraction in simplest terms. That means you don't have to give it in decimals. So if you use your calculator, you're going to get your answer as 125 by 6 units squared. Okay, so this is our final answer for question number 1. Moving on to the next question, question 2. So the diagram below shows part of the graph of y equal to x squared minus 4x plus 3. We have to find the area of the shaded region labeled R, basically this region. Now one concept please keep in mind, that is whenever we want to find out area of a region below the x-axis. So see, this is below the x-axis. So whenever we want to find out the area of any shaded region below the x-axis, the area will be the modulus of the integral that you will find. Because if you do the integration, you're going to get your answer as negative. But we cannot have area as a negative value, right? So we have to always use the modulus sign. So when we use modulus, we will just take the value. So we will drop the negative sign. So let's quickly look at the integration. So here same concept, to find out the area we use integration. So integral, now what's the upper limit? So here the two x values given are 1 and 3. So 3 is greater than 1, that means 3 is the upper limit and 1 is the lower limit. So write the upper limit over here followed by the lower limit at the bottom, and y dx, right? This is the concept. So what is y now? Y is x squared minus 4x plus 3. So integral 3(1) x squared minus 4x plus 3 dx. So if you want, you can integrate them together, or if you want, you can do them separately. So let's do separately. So 3(1) minus, so again 4 is a constant, so I'm writing that outside the integral sign, x dx plus 3 integral 3(1) dx. If you want, you can again write a 1 over here. or what did we learn? We can write also x to the power of 0. So next, normal integration, x cube by 3, 2 plus 1 by 2 plus 1. So limits are what? 3, 1 minus 4, x to the power 2 by 2. Why? Because this is 1, so 1 plus 1 by 1 plus 1. So this is our answer, 3, 1. And this is x to the power 0 plus 1, so 1 by 1. Okay, so I'm writing just x. And the limits 3, 1. So let's put the values outside the bracket. So 1 by 3 x cube, 3, 1. So this will go 2 times, so minus 2 x square, 3, 1 plus 3 x, 3, 1. So next step is what? Substitute the values of the limits in place of x. So 1 by 3 bracket 3 cube minus 1 cube bracket close minus 2 bracket again 3 squared minus 1 squared bracket close plus 3 bracket open 3 minus 1. Right, so next step. So this is going to give us 27 minus 1, so 26 by 3 minus 9 minus 1, 8, so 2 into 8 plus 3 times of 2. So if you solve for this, you're going to get negative 4 by 3. So we cannot have area as negative. So our final area will be modulus of minus 4 by 3, and that is going to give us just 4 by 3 units squared. And this is the answer for question number 2. So previously, see, it was above the x-axis, so we did not have to take any modulus because our answer came as positive. But here, since it's below the x-axis, so please remember to take the modulus of it. Now the last question. So see, this time we are given two equations. One equation of a line. So as we can see in the diagram, there is a line and there is a curve. Right? So here y equal to x plus 2. Naturally, this is the equation of the line. And this one, which is y equal to 10x minus x square minus 16, is the equation of the curve. So we have to find out the exact area of the shaded region. That means we have to give our answer as a fraction. Please don't give your answer in decimal if they mention this term, exact. So now if we look at the area, so see here, this is the shaded region. This gray part is the shaded region. But if we want, we can split it into a trapezium. How? Let's see. So see, this is a point of intersection between the curve and the line. So if I want, I can drop a line from that point to the x-axis. So this is basically the x coordinate of that point of intersection. So how many points of intersection do we have? See, we have this point of intersection between the curve and the line. Let's call it P1. And this is another point of intersection, P2. So this x coordinate, let's call it x2, is the x coordinate of P2. So here this is going to be what? The y coordinate of P2. Right, so this is x2 comma y2. Okay, and if I do the same thing for P1, so this is the x coordinate of P1 and this is going to be the y coordinate of P1. So x1 comma y1, that's the coordinates of point P1. So first, let's look at the diagram that we have now. So here if you see, this is turning into what? It is turning into a trapezium. Right, so what we can do first is we can find out the area of this trapezium. So let's call this area of the trapezium A1. Okay, and if we remove that area, so we'll be left with what? This area, the one that I'm highlighting in blue. So let's call that part of the area A2. So the total shaded area will be A1 plus A2. So first let's concentrate on finding the value of A1. A1 is the area under the trapezium. So what's the formula for area of a trapezium? So area of a trapezium is half A plus B into H. Basically from here to here is the value of A, and from here to here is the value of B, right? And H will be from here to here. So first let's find out this part. So this is basically what? This is the point where the line is crossing the y-axis. So y-axis equation is what? X equal to 0, because any point on the y-axis will have x coordinate as 0. So equation of the line is what? Y equal to x plus 2. So if x is equal to 0, so when x is equal to 0, what will be y? Y will be 0 plus 2, which is 2. That means this point is what? 0, 2. So the y coordinate is 2. This is the origin, that means this is 0. So what is A? A is basically 2. 2 minus 0, which is 2. Next, what we need? We need to find out the value of B. And B is what? B is basically y2 minus 0. Right? This is y2 minus 0, which is simply y2. So we need to find out the y coordinate of P2, because y2 is the y coordinate of P2. And what is P2? P2 is a point of intersection of the curve and the line. So whenever we want to find out points of intersection, what do? We equate the two equations. So here the line and the curve is intersecting, so we have to equate the equations. So it will be x plus 2 equal to 10x minus x square minus 16. So why did I do it again? I did it to find out the points of intersection. So let's bring everything to one side. So I'm bringing all the terms to the left hand side. So it will change to x squared plus x minus 10x plus 2 plus 16 equal to 0. So x squared, x minus 10x, that's going to give us minus 9x plus 18 equal to 0. So we have got one quadratic equation, and to solve for x we can use middle term factorization. So x squared minus 6x minus 3x plus 18 equal to 0. So I can take x common. So x bracket x minus 6. Now from this side let's take minus 3 common. So minus 3 bracket x minus 6 equal to 0. So what are the two factors? X minus 3 and x minus 6 equal to 0. So from here what will be the two roots? One will be x is 3 and the other one is 6. So x as 3 is basically what? x1, which is the x coordinate of P1. Right? So if I zoom into the diagram again, this is 3. And x2 will be what? x2 is this value, which is 6. So h is x2 minus 0, right? So x2 minus 0, which is 6 minus 0. So we have got the value of h. So next I need to find out the value of y2. So for that I can use either the equation of the curve or the equation of the line. I'm going to use the equation of the line because that's simpler. So equation of the line is y equal to x plus 2. So I already know the x coordinate, which is 6. So y2 will be how much? 6 plus 2, which is 8. So this is equal to 8. So b will be what? B will be y2 minus 0, which is 8 minus 0, 8. So this is 8. So I have now found out A, I have found out B, I know H. So I can find out the area of the trapezium, which was A1. So half into A plus B into H. So half into A was 2, B is 8 and H is 6. This goes 3 times, so 10 times 3. 30 is the area under the trapezium. So we are done with finding out A1. So next what I have to find out A2, which is, if I look into the figure again, this blue part. So here, see, we already know this x value. So next I need to find out this x value. Right, I'm only drawing this part of the figure. I think it will be easier for you guys to understand. Okay, I'm drawing this part of the graph. So this is the curve. Okay, I need to find out this part of the area, which is our A2. So I already know this x value, which was x2, 6. So I need to know what is this point, because if I use integration, this is going to be my lower limit. So I need to figure out what will be my upper limit. So this is basically what? This is a point where the y is touching the x-axis, or the curve is touching the x-axis. So in the x-axis, all the points have y coordinate 0. So the equation of x-axis is y equal to 0. So if I want to find out the x coordinate of this point of intersection, I simply have to equate this to 0. Equation of the curve, that should be equal to 0. So 10x minus x squared minus 16 equal to 0. So I'm bringing all terms to one side. So x squared minus 10x plus 16 equal to 0. So again I can solve it using middle term. So x squared minus 8x minus 2x plus 16 equal to 0. So x bracket x minus 8 minus 2 x minus 8. So x minus 2 and x minus 8 are the two factors. So one x coordinate is 2 and the other one is 8. That means these are the x coordinates of the points of intersection of the curve with the x-axis. So why did I do this? I did this to find the points of intersection of the curve with the x-axis. So where are the points of intersection? This is one point, let's call it P3, and this is another point P4. So P3's x coordinate will be 2. We won't really need this. And P4's x coordinate is 8. So this is 8. That means if I come back to this figure, this is 8. So the upper limit I now know is 8. So now A2, to find out A2 we have to use integration. Upper limit is now known, which is 8. Lower limit is 6. Y dx, where y will be the equation of the curve. right? So integral 86 y is 10x minus x square minus 16 dx. So now let's integrate. So 10x square by 2, 8, 6 minus 1 by 1 by 3 x cube, 8, 6 minus 16x, 8, 6. So this goes 5 times. So 5 bracket. Now substitute the limits in place of x. So upper limit 8 square minus lower limit 6 square bracket close minus 1 by 3 bracket open, 8 cube minus 6 cube bracket close minus 16, 8 minus 6. So if you solve for this, you're going to get 9 1 by 3. So this is the value of A2. So what did we say our total area was? It was A1 plus A2. So therefore our final answer will be A1, which was 30, plus A2, which is 9 1 by 3. That will come to 118 by 3 units squared. This is our final answer. So this is how we have to solve area under a curve or area for shaded regions. Thank you for watching my video. If you find it useful, please subscribe to my channel. I'll be uploading more videos soon. Bye bye.